मजा ही आ ब्लेसिंग दे अरे क्या बता भैया क्या बता जल्दी क्या बोलूं भाई मैं अब यार क्या 10 क्या वो इसे जो किया था ना मेरे साथ अरे इसे किया था ना तेरी लिस्ट सालो क्या किया तुमने Yes. What is the lens? Who answer? Raise your hands. What is a lens? Keep your bags inside or behind. Keep the passage clear. What is a lens? Not mirrors. Lens में mirror कैसे आएगा? So I think we discussed about it in the last class. What is it? Bound by this is Did we discuss it in the last class? Yes. So I think we have already done it. It was last class में किया था. Refraction fire lens. There are how many types of lenses? Convex or silence. Convex lenses also called converging lenses. What about the other lens? Or diverging. So what is the difference between two lenses? Convex is inner at the edges. Whereas concave is inner at the edges. Inner is so inner at edges. Inner spelling correct? Inner at edges. Thicker in the middle. Where it is thicker at edges. And thinner. Now, in the last class, I think I explained it quite hurriedly how the refraction process takes place, right? So you can imagine the lens to be a part of lens is made up of. These are basically thin lenses. So you can treat this as a prism, this as an inverted prism, and this as a glass slab, rectangular glass slab. Okay. All four rows get up, four rows get up and push it back. Who's the test bed? Why madam came? Sit down, sit down, sit down, sit down. So you can see that the lens can be thought of as made up of two prisms, not pyramids. Prisms and a rectangular glass slab. Okay. And you know what happens when a light enters through a prism? It bends towards the base. So let us say the light comes here from the upper part of the lens. So this is one normal, so it will bend towards the normal. And then this is the second normal, it will go further away from the normal. Okay. So this is how it should have. Right?
Yes.
And if this is a rectangular glass slab,
Yes.
the ray will pass without any deviation. Because it is falling, let us say, perpendicular to the surface. So this will go undeviated. Okay? So no deviation over. Over here, again it is an inverted prism. So first bending inside like this, then another bend. And it should pass through focus. Two bendings are there, right? So generally, the refraction is taking place at two surfaces of the prism. But in the ray diagrams, we won't be showing it again and again. This is just one time to explain how this is happening, right? Likewise, in this case, this could be treated as a prism with a head chopped off, right? And this is also a prism with head chopped off. This can be treated as rectangular glass slab. So here the base is the base. So any ray coming like this, so it will suffer refraction twice. So it goes like this. Likewise, it will also bend towards the base. Okay. First here and then further. So the refraction is taking place twice like this. But in actual ray diagrams that we'll be drawing, so for this case, we'll be drawing like this. So let's say this is the center of the lens. So we'll bring the rays till the center and then just one bend you will see.
Yes.
Not two bends. This is how you have to draw the ray diagram. Is the difference clear?
Yes.
So it is not required because now it is understood that you know how the refraction is taking place. Okay. So now you'll be drawing like this till the center of the lens and then whether it converges or diverges. Is that clear?
Yes.
Okay. So this was in unit 1, unit A. Then there is a concept of first principal focus and secondary focus. Okay. So let's understand that. This we have already discussed. Okay. Can I erase it?
Yes.
Now we discuss what is called as principal focus. Close the book. This chapter you just close. Everybody close the book. Keep writing the notes. That way it is better to understand. Everybody close your books. The principal focus is F1. And secondary, right? What is the second one? First, so this is also called first focal point. First focal point and second focal first focal point. F1. And so let's understand what is first focal point. So now you have two spherical surfaces. Now you know that how the lens is made. It is cut from a sphere, right? So that sphere would have a center. So therefore lenses will have two focus. One on this side and one on this side. Okay. So which is the principal or first focus? So it is the point. Let's say this is the radius of curvature. Focus will be at half of it. So this we call as first focus. Why do we call it as first focus? Because any light emanating from it okay, silence. Pay attention over here. Any light emanating from the principal focus after refraction, it becomes parallel. Okay, then this is called first focus. So if this is the first focus, then the second one will be on the right side. And double the distance. So we call it double the distance is 2f1. And this is f2. So this will be 2f2. What is 2f2? R2, basically. Radius of curvature on the other side. And this is radius of curvature on the left side. Right? So this ray passing through the middle is called principal axis. Line joining the center of curvature, focus, and the optical center is principal axis. So this is your familiar. Now instead of concave lens, what is the principal focus or first focus in case of in the concave lens? What was the definition? Light emanating from the focus should become parallel after refraction. How will the light become parallel after refraction here? Because so here, let us say the light is coming towards the focus. Okay, so then after refraction, it becomes parallel. This is coming towards the focus. So this is now the principal focus. In this case, right? So it is diverging. So basically, after it emerges, it will become parallel. So the refracted light ray should be parallel. So that becomes then the first focus. So you have to keep this in mind. Whenever you draw the ray diagram, the order, like for this, for convex lens, F1 will be on the left side. For concave lens, F1 will be on the right side. So here what it will be then? Other is F2. So here F2 and 2F2. फिलहाल बाहर जाके whistle करना है. Last warning. So this is F1, F2. Is this clear? That's how it is defined. Because the refracted ray should be parallel, right? So when will you get refracted ray parallel in case of diverging lens? Only when it is incident towards this focus. Then we define this as first focus for concave. Okay, so the hint is refracted ray shall become parallel. This is the hint to remember. Okay, this is the hint. Refracted ray should become parallel, and that focus is the first focus. And since there are only two focus, this is parallel, it is looking diverging. So just make it parallel. So with this clarity, let's move on to second unit. Age formation. This is unit B now. Four units. Let's focus on B right now. So what does it deal with? Formation of images. First by convex lens. Okay. So do you remember formation of images by concave mirrors? Yes. There were 6 object positions for concave mirror. Infinity, beyond C, beyond F, infinity is at C, between C and F, at F, between F and O. Same nature will be obtained in case of image formation by convex lens. Okay, what you obtained for concave mirror, exactly same nature in case of convex lens. Let's verify. So let's take the first object position as object at infinity. Infinity. So where should be the image form? At focus. Right? There you go. So whenever the images are, whenever the object is at infinity, the image will be formed at. Yes. So how to draw the ray diagram? First you draw the lens. Then mark 2 points on the left, 2 points on the right. Do not label it at this stage. First draw the ray diagram. So when the object is at infinity, the incident ray will be parallel to the reflecting surface. Principal axis. Parallel to principal axis. Right. And all the parallel rays will, after refraction, pass through focus. This is a rule. Okay, now label. So this was F1, this is 2F1, this is F2, and this is 2F2. So for object at infinity, what is the image position? Image at F2. You give the name of the focus, F2, so that you know it is on the right side. So which 2 rays we need for image formation? Ray parallel to principal axis, ray coming towards focus, right? So these are the 2 rays we will take. Okay. So now image at F2. What is the nature? Sir. Inverted. Why real and inverted? Because the rays are physically meeting after refraction. So that is the condition for real image formation, that after refraction, the rays should physically meet. So wherever they are meeting, that is the point where the image is formed. So that's nature. What about size? Highly different. This was also the case in case of image formation by concave mirror. Same thing. But what was the difference? Image is formed on the same size, same side. Okay, because it is reflected. In this case, it is refracted. So only difference is in the image formation in terms of side. So it is behind the lens. In case of mirror, it is in front of the mirror. Okay, front is this side. This is front. This is behind. This is the only difference. Everything else is same. क्या हुआ? क्या पूछना क्या हुआ? Irregular में मत जाना, पहले regular तो समझ ले. Okay, second is what object position? What object position? Infinity, then beyond 2F1. Far from. Second case is object beyond F1. Why are we saying beyond? Because always the object is on the left side and front, so beyond, away from the lens. Reference is optical center, so away. That's why beyond, right? क्या हुआ? What is the step? First you mark F1 to F1, F2 to F2. So A side mark. So where is your object now? Beyond 2F1. Here. So now the object is closer to the lens, right? So we have an object size now. So we need 2 rays at least for the image formation. So one is parallel, another you can pass it through optical center also. Yes. It will pass undeviated, right? And the one which is parallel will pass through focus. Where are you getting the image? You're getting the image also. What is it? F2. This is F2. This is A dash and B dash. So where is the image forming?
Sir, in the middle of F2 and 2 and 2 F2 and
You say between
F2 and 2. Nature, real and
F2 and F2. What is the not understand? Parallel ray to principal axis after refraction will go through focus. That is the rule. Any ray which is passing through the optical center, there won't be any deviation. Right? That's the special case. See, the principal axis, it's not deviating. Anything that passes through optical center, there will be no deviation. That's different. So it is okay. First, let me finish it. I'll explain you. So what is this? Now the first thing is image position. Second is nature. Third is size. Nature is real and inverted.
Real and inverted.
What about the size?
Same size as the object.
Oh,
So sir,
diminished.
Sir, how diminished?
Same when it is on 2F1 or at 2F1. It is not. It is beyond. Diminished. Okay. All real images will be inverted. Remember that. So this is diminished. When it is kept at C, तब होगा ना C पे कहाँ है? Next condition is now what is the focal plane? Everybody understand what is the focal plane? Focus, everybody understand. What is focus? Point on principal axis. Where the rays parallel to principal axis converge. That is your focus. But what is focal plane? Plane which passes through focus and it's perpendicular to it. Right? So let us say you have a lens like this. So when you have light which is parallel to principal axis, it focuses at the focus, right? Look here, you asked the doubt. So pay attention. When the rays are parallel to principal axis, it converges at focus. But what if the rays are not parallel to principal axis but parallel to themselves? So these are rays parallel to themselves, right? Yes. But not parallel to principal axis. Then what happens? So suppose this is focus, this is focal plane, right? So now these rays will be focused over here, let us say. Where is this? This will meet somewhere here. This will meet over here. This will meet over here. When the rays are parallel to themselves, but not parallel to principal axis, it meets in the focal plane somewhere. That's what it is. But you won't be having any case for this. Okay? So this is focal plane. Got it? So just if there is any ray diagram, for that only. But all the practice will be rays parallel to principal axis. Huh? Parallel to. Now third. What should be third object position?
Sir, at
Object at
2F1.
2F1. Draw the ray diagram, everybody.
Okay.
I am telling you the position. Image position should be 2F2. Real and inverted.
Same size.
Same size. This is what you should get. Everybody draw the way for this. Without arrow, your arrow or direction, your ray is
Object at left.
इसका डायग्राम कंप्लीट हो गया मेरे को बुलाओ बुक्स क्लोज हाँ एवरीबॉडी बुक्स क्लोज Raise your hand if you have completed the diagram. Direction, everywhere. Direction, all the diagram. Object is captured 2F1. वो तो तुम यहाँ से बना सकते हो लेफ्ट साइड में ऑब्जेक्ट कहाँ पे आएगा 2F1 पे वो पार्ट सबको आना चाहिए तो सबसे पहले वो बनाओ
मेरा भी सही है
क्या नहीं आ रहा है देखो तुम लोग को मैं एक ट्रिक बता रहा हूँ Draw the diagram symmetrically. Symmetrically का मतलब क्या हुआ? समझो तुमने O से डिस्टेंस मेजर करो 3 सेंटीमीटर और 3 सेंटीमीटर ठीक है O से 3 सेंटीमीटर लेफ्ट और 3 सेंटीमीटर तो ये हो गया तुम्हारा वैसे ही फिर से 3 सेंटीमीटर 3 सेंटीमीटर समझ आ गया सबसे पहले तुम्हें ये मार्क करना है तुम्हारी O से ये डिस्टेंस जितनी है उतनी ये डिस्टेंस डबल होनी चाहिए एग्जैक्टली तो रे डायग्राम परफेक्ट आएगा ठीक है और so there is a sense in it so now it is these points are symmetrically away from the optical center now don't label it right now first complete the ray diagram you just mark the points and then complete the ray diagram let us say the ray diagram तुमने यहाँ पे AB रख दिया object name is always AB now what do you need for image formation you need two rays also two rays one parallel and one passing through optical center optical center only straight हो जाएगी तो सबसे पहले optical center बनाओ ये बनाओ ठीक है now we know that this must fall here we know that this must fall here so second ray which is parallel it must pass through focus and you already mark the point यहाँ पे ठीक है इसका मतलब ये ज्यादा बेट होगी इसका जो साइज है बराबर यहाँ पे बना लो पहले ठीक है बना लो पहले से सेम साइज जो इसका साइज है उतना यहाँ पे बना लो एंड देन ब्रिंग दिस टू रेज This is the trick. Okay, know the nature. So, so the labeling has to be correct. The image has to have dash.
Yes.
A, B, object labeling, A dash, B dash, image labeling. Now here, the image should be of the same size. So what is the pattern here? Pattern is when the object is at infinity, the image was point size. When the object was at infinity, image was highly differentiated. As the object comes closer to the lens, the image size increases and it goes away from the focus, right? Towards the lens. Goes, or in this case, it goes away. Mirror में क्या हो रहा था? It goes away from the focus, right? C की तरफ आ रहा था. Mirror में. यहाँ पे भी C की तरफ जा रहा है दूसरी side में. C means center of curvature, right? So as it goes away from the focus, the image size increases. ठीक है? Till when it increases and becomes equal, when it is exactly at C. After this, you will get magnification. So when the object now comes between 2f1 and f1, now the image should be magnified. This is the pattern. Okay? Chalo, draw the next one. Draw the next one.
Sir, next one, like
Object between 2f1 and f1. There are 6 object positions.
beyond.
Beyond 2f2, right?
Yes, yes, sir.
You got it?
Yes, yes, yes. Yes, sir, yes, sir.
Okay. So, object between 2f1 and f1. Now I am giving you the nature. Image is
Magnified.
beyond
Real,
2f2, real and inverted. Are the rays physically meeting?
yes.
Yes, so real and inverted and magnified. Draw the ray diagram. I will come and check. Even if what kind of image is there. Three head with one power. Try to with the scale on. This is not a part of the mention there is a outside the extra. Right. Okay, good. सबका बियॉन्ड आया ठीक आ गया डायरेक्शन Direction. So I think most of you have got it. किसी को नहीं समझ आ रहा है तो पूछो. Easy, right? Look at the diagram. Parallel is going to focus on the other. Where is your parallel? All your diagrams are on the right. तो समझ आ गया फिलहाल तुम्हारा डायरेक्ट देखो ये वाला समझ नहीं आया समझ आया तो ये बनना चाहिए ना तो बिलाल को नहीं समझा और कोई है जिसको नहीं समझा अभी देखा Yes, sir. Answer. What is the next object position? Add F1. क्या होगा? अब उसको add F1. क्या होना चाहिए? Yes. Infinity sir. बन गया चलो बनाओ देखो जो फर्स्ट केस था ये उसका उल्टा है when the object was at infinity then the image was at focus now object at focus the image will be at infinity ठीक है बनाओ Hold down.
पीछे देखा
अरे इसका ढक्कन है
को बंद करके
इसने पीछे
ये ढक्कन
चलो एवरीबॉडी Guys, stand some of you outside.
Yes.
मेरे को बताओ कि किसको किसको भेजना है.
इसके बाद
ठीक है. तो वहाँ पे जाके इमेज बनेगी इंफिनिटी. सो इमेज एट राइट. ये क्या हो गया? F1 F2 F2. कुछ नहीं कर रहा है ना तू. ये पूरी टेबल जिसके रेड डायग्राम कंप्लीट नहीं होंगे ना लेक्चर के बाद रुक के कंप्लीट करके जाएगा. सो इमेज एट इंफिनिटी. उसके बाद नेचर क्या होगा? रियल एंड इन्वर्टेड. क्योंकि जो भी इमेज लेंस के बिहाइंड बनती है वो सारी कैसी बनेगी? रियल एंड इन्वर्टेड. जैसे मिरर के केस में क्या होता था? रिफ्लेक्ट होके जो फ्रंट में बनेगी वो कैसे बनेगी? रियल एंड इन्वर्टेड. मिरर के केस में यहाँ पे क्या होगा? बिहाइंड द लेंस जो भी इमेज बन रही हो कैसी होगी? रियल एंड इन्वर्टेड. यस, रियल एंड इन्वर्टेड. अब बताओ ये क्योंकि इंफिनिटी पे जाएगा तो उसका साइज बढ़ते जाएगा. हाईली मैग्नेट इंफिनिटी पे. अब तुम ढूंढो कहाँ है ना. तो अब देखो ऑब्वियसली ये जो दिख रहा है वो तो इंफिनिटी नहीं है. बट ये भी जा रहा है आगे. ये साइज कितना हो रहा है? हाईली मैग्नेट. क्या हुआ? क्या हुआ? हो गया. प्रैक्टिकल मीनिंग होता है रियल पावर ऑफ इट. अगर वो बिल्डिंग है मेरे लिए इंफिनिटी यानी मेरी सारी बिल्डिंग से पैरेलल है. ये तो ये विंडो का हाइट है. ये विंडो का हाइट कितना है? तो उस बिल्डिंग की हाइट और क्या है ना बिल्कुल पूरी बिल्डिंग जो भी पावर ऑफ इट डिस्टेंस क्या हो गया? Is everyone good with this? This is homework for Bilal. Everybody help him get it if he asks. ठीक है? नहीं पूछेगा तो कोई बात नहीं. तो मैं वो नेक्स्ट टाइम करके दिखा. तुम लोग मुझे याद दिलाओगे. लाल ये लिख. नेक्स्ट क्लास में अगर नहीं हुआ बाहर बैठ के पहले बनाना. ये वीडियो में आ चुका है. What the last object position? Object between F1 and चलो ये बनाओ सर इसमें क्या आएगा बन गया क्या होना चाहिए
सर
वर्चुअल होता है वो कैसा होता है अपराइट सब लोग बनाओ लेट मी चेक
सर एक सेकंड ये देखो
सब देखने तो मैं डायरेक्शन क्या कर पैरेलल है क्या है पैरेलल है तो गलत नहीं बनाना ना सही बनाना उधर क्या है सबसे इधर एक पेन से हम भी पेन से बना रहे हैं कोई स्केल यूज कर रहे हैं क्या समझ के बनाओ उसको और डायरेक्शन ठीक करो उसका डायरेक्शन और वर्चुअल इमेजेस शुड बी डॉटेड ये देखो
ये टेकिंग के वर्चुअल
सारा रेड आएगा ऊपर का प्रैक्टिस की ठीक है अरे प्रैक्टिस और से आगे बना के लेके आना देखो आप एडमिटेड नहीं कर ठीक करके आना अगले क्लास में सारे रेड आएगा ये जिसके भी डायग्राम ठीक नहीं आ रहे ठीक है सारे डायग्राम
नहीं हो रहा पता है
बना के
But one more
ऑल यही तो है सारे छह इसके हैं और कॉनकेव के और दो है बस टोटल कितने हैं एक तो हमने 6 तो भी कंप्लीट करेंगे सो अभी यहाँ पे क्या है ये सबको बना के लाना ही है ठीक है क्योंकि बहुत लोगों के जो रे डायग्राम्स है वो ठीक नहीं है तो पढ़ो तो बना के लो नेक्स्ट इज फॉर्मेशन अब ये कहाँ पे हमारा ऑब्जेक्ट है कहाँ पे ठीक है ये सबका आ गया है ना इसका नहीं है यार
हो गया सर
ये पैरेलल है, ये तो पैरेलल है, तो डाइवर्स वर्चुअल इमेज है ना, तो ये डॉटेड है ही। वर्चुअल इमेज का कैसा आएगा? डॉटेड। ये हो गया, ये है साइलेंस। आपकी बात सर पे पड़ेगा, जो भी बात कर रहे हैं।
सर इसका
और
है
यही सबसे बड़ा आज समझ लिया। इसको दे दे और चुपचाप रख दे। सबको समझ आ गया ये? ठीक है। नाउ इमेज फॉर्मेशन बाय कॉन्केव लेंस, दो ही पोजीशन है। तो क्या होगा इसका? देखो इमेज है इन फ्रंट ऑफ लेंस, ऐसे लिखेंगे। ठीक है, इस केस में वी विल नॉट स्पेसिफाई कहां पे, विल जस्ट से इन फ्रंट ऑफ लेंस, इमेज इन फ्रंट ऑफ लेंस। अच्छा, कैसा है? वर्चुअल एंड highly कैसे? You can see it's only 2-3 times. Highly magnified comes up infinitely. So you can see that convex lens में all types of images are formed. Real, virtual, ठीक है? Diminished, same size, magnified, all kinds of images are formed. But concave में only virtual image will be formed. Image formed by convex lens. Convex lens में खाली दो ही पोजीशन, कौन सा? Object at infinity मेरी आवाज सबसे ज्यादा आती है फिलहाल के बाद।
सर मुझे छोटा बोलने
ठीक है, और पीछे कुछ परफॉर्मेंस है बातचीत करने। चलो, ऑब्जेक्ट एट इंफिनिटी कैसा बनेगा इसका इमेज? सबसे पहले लेंस, फिर प्रिंसिपल एक्सिस, उसके बाद मार्क फोकस, सेंटर ऑफ कर्वेचर, फोकस, सेंटर ऑफ कर्वेचर। ठीक है, ऑब्जेक्ट एट इंफिनिटी, तो रेज विल बी पैरेलल टू प्रिंसिपल एक्सिस। अब क्या होगा ये? It will be diverse away from the focus, away, ऐसे। You keep your scale such that it is at these 2 points, then away from the focus. So extend it backwards, so it will come at focus. This is away from F. No, this is now F2. So यहाँ पे again it will go away from F2. ये हो गया। So what is the nature of image? Image at F2.
real and virtual and erect.
Virtual and erect, yes. Single arm. Then highly diminished. Second क्या है?
Object at
Object between infinity and optical center. इसमें दो ही ऑब्जेक्ट पोजीशन. Object between infinity and optical center. Optical center. Oh. Mark points. Yes, this is F1 and 2F. So infinity and okay, maybe let's say you are keeping the object here. It will go away from next we will take it from
Yes.
so from where this object is, where is the image from? Here. Because anybody seeing the image, he will feel that these two rays are coming from here.
Here.
So what is the image position?
Between
Yes. It can never be beyond F2. Image between F2 and home. Virtual and diminished. So in concave lens, only diminished images will be there, and only virtual images. There is no real element. Okay. So this completes our discussion on image formation by lenses. Okay. So I'll see you in the next class.
All the